All right, folks, thanks so much for joining us today for this RCR Wireless News webinar on getting small cell networks right. I'm Kelly Hill, editor with RCR Wireless News and the author of our most recent special report on this topic, which posted today on our website, rcrwirelessnews.com. Let me give you a quick introduction to our panelists today. We have Emil Ulbrich, who is Vice President for Network Technologies at Signals Research Group, Dennis McCall, PMTS Maintenance Engineering at Verizon Wireless, and we also have Dan McVaugh, COO of Centerline'S Solutions. So we'll be running through presentations from all of those folks first, and then we'll be diving into Q&A. Please feel free to submit questions. The slide deck will also be available to our participants after the webinar. Just a quick news update, some of the small cell developments that have been in the news recently. We had Verizon signing a national small cell infrastructure agreement in January with street furniture company JCDecaux. We also had Ericsson and KDN utilizing C-RAN small cell architecture in street furniture in the Netherlands. Small cells in San Francisco boosting capacity during the Super Bowl, and if I remember correctly, that also involved street furniture. And Extenet, Verizon Wireless particularly talked about some of the things that they did there, and I think we'll hear more from that, more on that from Emil in a bit. We also saw enterprise small cells with a boost in 2015, according to numbers from mobile experts. And the overall market there for small cells one projection from Radiant Insights expecting to reach $6 billion by 2019. So those are just some of the things that have been in the news lately on that small cell topic. It's definitely getting a lot of attention right now as carriers put more focus on this area. So looking into our Getting Small Cell Networks Right special report, again, available for free download on rcrwireless.com. Some of the key takeaways from that report include talking about how ecosystem partnerships, master use agreements, services, tools, all of these things are contributing to better efficiency and streamlining when it comes to small cell deployment. And that's contributing to the momentum that we saw in 2016 and continuing forward from 2016 onward. When we think about tools when it comes to small cells, some of the folks that I talked to, talked about things like analytics, geolocation information, simpler walk testing and fiber testing equipment, backpack setups, etc. Information-rich databases, just one example in the form of Nokia networks, HetNet engine room, small cell services from vendors. All of these things are helping the ecosystem tackle those small cell deployment challenges around backhaul, power, and site acquisition. They're not completely tackled, but we're getting there, I think, is generally what I've been hearing from folks across the ecosystem. Also, in general, that we're seeing more and more distributed network architectures, whether that's small cells, sort of as we've come to identify them, as more or less mini base stations, whether it's DAS, ODAS, or indoor DAS, in C-RAN. All of those are expected to continue growing as operators densify their networks. And interestingly, Internet of Things and 5G are also influencing small cell deployments and strategy with an eye toward using higher spectrum bands, thinking about the latency and capacity requirements for 5G, and also different Internet of Things strategies. So carriers have both of those things in mind as they're thinking about current small cell strategies now, with an eye toward what those are going to mean for their networks going forward. And with that, I'm going to pass this over to Emil, and he's going to walk us through his presentation.
All right, Kelly, thank you. And I'd like to thank you and RCR Wireless for this opportunity to present on some information on small cells. So without further ado, when we started looking at this, I took a look back in the past at a survey that was done, actually a survey of analysts, and you can go to the next slide, Kelly. And just looking 3 years back, you look at the hype, there was a lot of hype, and I kind of draw that akin to the HD DVD and Blu-ray fight and New Coke. But when you look at it, people were very excited about small cells, and including myself. We wrote a lot of articles about HetNet, how it was going to solve this explosion in mobile network utilization. And I guess in the U.S. we just didn't see that happen. We saw a lot of carriers purport to say they were going to put in, 30, 40,000 small cells by the end of 2015, and you see them retract that, and you kind of wonder what happened. When we looked at other markets, we look at Korea, they're almost in Seoul and outlying areas all the way down to Busan and other areas and provinces is almost 100% small cells, but their small cells are 20 watts. They have lots of capacity, lots of down tilt. They cover small geographic areas just like a small cell, but they're consuming all of that data. And when we started to look at the radio access network vendors, we saw that a lot of the larger RAN vendors, the big three now, were really developing other features that carriers are wanting them to focus on, primarily carrier aggregation and getting different bands approved through 3GPP and pushing that through. However, as we watch the standards industry and as we watch 3GPP, the carriers and with their vendors in tow are really pushing for small cell enhancements. So we still see it as a priority. Next slide. So I need to talk a little bit about our Broncos. Being here in the Denver, Boulder area, some of you may not know, but they are world champions. But looking at the Super Bowl and specifically Levi Stadium and the other venues for the surrounding week for all the media and all the events that happen prior to the Super Bowl, the four national network carriers, Sprint, T-Mobile, Verizon, and AT&T, spent, Kelly may know this, they spent over $200 million to add capacity to Levi Stadium and surrounding areas. But when you start to dig into it, you look at what was done. AT&T, they upgraded their DAS systems in all 26 venues. They added new cell sites, macro cell sites, and COWs, but no small cells. Same thing for Sprint. They nearly doubled their capacity in Levi Stadium, but it was all done with DAS upgrades. T-Mobile, same thing. They had a capacity of 150 sites surrounding the area, brought in COWs around the stadium. Verizon was the only one that really put in specific small cells and street furniture. And that showed they had the most data usage. Now, granted, they may have had more customers there, but they had 7 terabytes of data flow through their network during the Super Bowl. They also put in, 15 macro cells in addition to those small cells. Interestingly, Comcast, which uses Wi-Fi access points similar to a small cell type architecture with regards to the size of the coverage area, had over 10 terabytes of data. So they beat all the wireless carriers. Now, that was free as long as you had Xfinity access, but they did that and showed that architecture can be utilized specifically in a large-scale venue. Next slide, Kelly, please. So what's the problem? Why isn't there more testing? Why isn't there more deployment? When we started to talk to the marketplace, looking at what's available, initially multi-vendor support. Most of the enterprise small cells that we see getting deployed are, at least for outdoor small cells, are the same vendor between the macro site and the small cell. So X2 interoperability, and being able to exchange interference coordination and really, truly get SON working has been an issue. SON vendors have made a lot of promises, and in talking to the network carriers, they just don't believe that inter-vendor SON is working in LTE the way it has worked in UMTS and 3G. So that is still yet to be proven, I think, in a wide-scale basis, at least to the carriers that we talk to. Carrier aggregation has been a big part of it too. Getting multi-carrier small cells, they're getting more and more prevalent. But initially, they were single-band LTE. Now, as more and more bands are becoming available, you look at AT&T alone has 4 different band combinations and more getting on. And you have other carriers like Sprint with TDD and FDD integration, which is a problem. And I think Kelly touched on this earlier. The analysis of where coverage is needed is changing. A lot of crowdsourcing is being done. It kind of started with Speed Test, and now you have others like GroupMetric and OpenSignal, and they're even making big commercials about it and how many balls roll down and how much kind of coverage I have. So that is really starting to change the perception of where coverage is needed, how it's needed, and how to supplement that. And so we have webinars like this, and we concentrate on this, and I thoroughly enjoy this. But when you look at it, we're really talking about the enterprise market. And if you look at small cells that have been shipped, it's less than 5% of all small cells that are shipped. Yeah, this is kind of what this webinar is about, is that 5%. The other 95% really comprise the enterprise, sorry, not the enterprise, but the small home office or residential market. And the reason there's not a lot of testing is that that's sold directly to the consumer. So they have a known issue with coverage in their house or their basement or wherever they're doing business. So there's likely not interference due to isolation, RF isolation from the building structure. They're lower in power, and they can be deployed by the customer. They're paying for the backhaul, typically, a cable modem, and there's no optimization being done. Interestingly enough, you see programs now for the enterprise starting to take advantage of this. Carriers are now offering in-home small business packages for enterprise businesses where you can put it in an enterprise grade small cell that has 3 nodes on it and have coverage in your network. So we see that happening quite a bit. In the enterprise market, starting to take cues from the small home office market where it's a self-deploy kit and no optimization or testing is necessary. Next slide, please. So, however, we don't think the small cell's dead. In fact, it may be ready to explode. And part of that is we see a lot of utilization of unlicensed spectrum, a lot of movement in that place by non-traditional carriers and by large carriers. So in that space, you have LTE unlicensed or license assisted access, LAA, the 3GPP version. And with that, it's tied to a licensed cell. So if you are running LTE unlicensed in the 5 gigahertz band, you have to have a licensed anchor cell because that's downlink only. The uplink goes through the licensed cell. So that coordination between the LTE-U base station and the licensed base station, there has to be a lot of optimization, deployment strategies as far as timing and handover to the nodes, and all of that has to be taken into account. You add into that all the advances being made in Wi-Fi with 900 megahertz, 2.4, 5 gig, and 60 gig bands being made available. There are a lot of different bands. They propagate differently through building materials, and so the way they get deployed and the way they get integrated, especially with LTE Wi-Fi integration, that will be important to optimize those different touch points because as we know, people are making more and more of their data usage indoors. Probably 3/4 of all data sessions are indoors. So being able to optimize these very small cells, especially at the 60 gigahertz range, and integrate them in with the anchor license base station is truly important. And with that, I am done.
Okay. Excellent. So we are going to move on to Dennis McCall. Thank you so much for that, Emil. Folks, if you have questions, please get those in, and we will get to those once we're done with our presentations. And so we are going to move on to Dennis McCall of Verizon Wireless.
Great. Thank you very much, Kelly. I'm very happy to be here and very happy to participate in this conversation. I think it's a very important one. I think you're bringing together a lot of folks with different viewpoints, and we'll be able to discuss some of the gaps and some of the limitations, at least, and I will be able to provide at least the carrier's a viewpoint. Some of the questions that Emil brought up, they have great answers, and I'm looking forward to discussing them. Go ahead and just highlight the entire slide since I'm not in controlling, but everybody knows that we're basically accelerating, or we're proceeding to see an exponential growth in data, and there's more requirements, more devices, more types of devices, and we're really we have to embrace the fact that that's happening and look for capacity solutions. The competition is fierce. revenue growth is not keeping pace, so we have to look for ways to reduce our cost. We have to keep an eye on that, and we have to make sure that we're looking forward, not just this year. We need to be looking forward many years, so that as we're building these massive networks with hundreds of thousands of nodes, that we can pay for them. We can make sure that we're keeping an eye on our lease costs, our operations and maintenance costs, and our operations and maintenance requirements. Of course, we're not going to stop building, but we absolutely need to be able to keep control or maintain our quality that everybody is come to expect from Verizon Wireless. But that can't slow us down from embracing new technologies and new opportunities. And we have seen the legacy of Verizon is one of reliability, 5 nines reliability. And so that, to some degree, has caused us to pause when entertaining less reliable systems, like voice over Wi-Fi or eFEMTOs, where the backhaul requirement or the backhaul quality control is maybe not in our purview. That's coming from 20 years in a very quality-oriented company. It's a tough pill to swallow, but it's one that we absolutely have to embrace and that we are embracing going forward. Yeah, go ahead and go to the next slide. And go ahead and light it up. So we see the need to increase capacity, and spectrum is certainly a part of that. We know we have LTE-U coming. We have voice over Wi-Fi, which Wi-Fi should be considered an alternative. I think our customers have multiple ways to get their data or get their service. It used to be that they were dependent on the carriers alone, and then when they left their homes, they really didn't have that option. But we're seeing Wi-Fi is proliferated, and there's certainly an alternative, and Wi-Fi hotspots being integrated into handsets and having friends with alternate service vendors. Even in large venue situations, people will find a way. And one great thing about that is they get less upset. I mean, the customers are certainly, we're very sensitive to their needs and what they want. But if you have multiple sources or multiple ways to get back or get your data or get your service, you tend to be happier. And that's what we're talking about, developing all of these solutions, your narrowband LTE solutions, all of the C-RAN solutions, machine-to-machine solutions. We're embracing that, and we're moving forward, and we're making sure our customers are happy, but also we're maintaining reliability. The need for spectrum is coming, right? Well, it's here, but there's a lot of new features that are coming out, or new systems, new protocols, LTE-U, and the discussion about 5G is very exciting. We're going to higher and higher frequency bands that we wouldn't even have considered a few years ago. So it's very exciting, but we're holding on to a lot of spectrum as well. And the use on our EVDO services and CDMA services, they're both waning, right? They're going to be going down, EVDO a lot faster than CDMA, but we're going to have spectrum that we can refarm, and we're going to be doing that aggressively. We already are. But the trend, as we're building these heterogeneous networks or these enhanced toolkits, I like to call them, they're still going to include macro cells. But we're also having to embrace new systems, your spider clouds, your eFEMTOs, your voice over Wi-Fi. And as we fill out this toolkit, we'll continue to deploy the right solution at the right location. Go ahead and go to the next slide, Kelly. Thank you, and light it up. So small cell deployments, I think a few years ago, there was an expectation set that we're going to deploy these things by, every day, hundreds, all the time, everywhere. But the actual operational limitations associated with these deployments and the costs for backhaul and the costs for leasing, they were no different than your macro cells. The people that were leasing this property expected macro cell money, and the backhaul associated with that is macro cell money for the backhaul. So if you're going to build a very small footprint service and you're going to have to pay macro cell money, the tendency was to try and get macro cell performance out of it. But now over the years, we have been able to develop these alternative agreements with, we're thinking out of the box. We're trying to find ways that we can deploy that are going to reduce these costs going forward. Since our revenue isn't growing as fast as it was, we have to do that. And we can't just aggressively start deploying without knowing where we're going to be 5 years from now. And that really was the cost. I think there was sticker shock associated with the cost of deploying a small cell, but now that we've figured it out and we're figured out these ways to deploy them intelligently and reliably at lower costs, you're seeing them happen. You saw it at the Super Bowl. And looking at the Super Bowl is really, it's a crystal ball as to what we're going to see in the very near future. You can bank on it. Data's going to go up and you're going to see more small cells. And I wouldn't call it an explosion, but an exponential growth that is started out very slow, but it's going to pick up speed, a lot of speed. And you'll see that same speed pick up with alternative solutions such as eFemto and Spider Clouds and whoever's going to be next in that toolkit development. So, but we're focusing, when you look at where small cells are being deployed, they're in dense urban locations, very dense urban locations. You look at some of these maps, and you look at these dots on the maps, and they are where the people are. You're not going to put a small cell in the middle of nowhere. That's not the purpose of it. Getting these devices very close to the customers is how you're going to get higher SINAR, and that's exactly where you're going to get your capacity. Continually, and when you compare the addition of spectrum and the improvement of SINAR, improved SINAR is going to deliver much more capacity than enhancing spectrum or deploying more spectrum. So, but we have to get these devices right next to the customer. You look at a 60 gig device of some kind, you're talking about a service area of maybe 150 feet. That's without obstruction. So you're going to have to get smart about that and figure out how that's going to look. And you have to remember, the folks that have been doing RF in this space, and 5 gigs high. You look at the antenna sizes and the dimensions and the performance characteristics of these 5G discussions, and it's going to be different, but we're going to have to embrace that. When it comes to small cell testing, we have to make sure that as we're deploying all of these systems, we have the quality controls in place. And we have to make sure that we have the ability to monitor the performance of these small cells, deploy them, and control them. That means, and then that's one aspect of small cells that is often overlooked, the fact that people have to be able to monitor them. And if you buy somebody else's small cell, you're going to have to invest in their operations and maintenance tools. And if you do that, that means that the people that work on these systems have to have that training and have to have that experience. And it's probably going to take a few years for them to ramp up. So you can't just go out and buy somebody else's gear. Not if you want a reliable system. You have to make sure that the people that are on the ground know how that stuff works and they have experience with it. And you have to have it figured out long before you deploy. That's why it's taken us a while. But we also have to keep our eye on the RF ball. We have a strong focus on making sure that we're developing our people, our technicians, and so that they have the RF fundamental background so that they can embrace these problems and solve them simply. Instead of throwing money at a problem, they need to be able to know when to engage and when to pass. And that's where we need to spend a lot of emphasis. I think that's about it for me.
Okay, great. Well, then, Dan, we're going to move on to you.
Great. Thanks, Kelly, and thanks again for the opportunity to speak today. At Centerline, we're a full turnkey services company that we design, build, modify, and maintain wireless networks. So today I'm going to speak from our perspective of kind of the rubber meets the road on what we've seen the last 2 years. And my focus is more on outdoor small cell. Indoor small cell we've been deploying for 5, 6, 7 years, but the last couple years, I think, and a lot of the focus of what Dennis and Emil have been talking about is really focused on outdoor. So, and what I'm going to talk about is, as we've been doing, whether it's RF, SIDAC, A&E, construction, maintenance, the 3 main factors that we're seeing that really impact the successful deployment are, of course, the size of the equipment, but not just the equipment, but the size of the overall site, all ancillary equipment as well as obviously time to deployment, and then of course the dollars. What are the actual direct CapEx and OpEx impacts that we've seen in actual deployments? From a small cell standpoint, PCIA defines the size of a small cell very specifically. They say it's less than 17 cubic feet. in equipment size and less than 3 cubic feet in the antenna enclosure. And there's some very specific definitions that people are trying to wrap around small cell. But our perspective on it is that really at the end of the day, it's figuring out a way to do things faster with less equipment, smaller equipment for less money. And so I don't know that the definition falls into such a clean box, but it's just more a matter of if you can do it quickly with less equipment, simpler equipment for less money, then I think that it fits into that category. So from a CapEx standpoint, we're talking about, it needs to be in the target of, a fraction of the cost, 10% of the cost, half the amount of time. So go ahead, Kelly, you can go to the next slide, that's fine. So, we've seen a number of great deployments where small cell deployments are going quite well, and we've seen others that they've gone not so well. But that doesn't necessarily mean that they've gone badly. It's just what we're seeing is, as you see on the left, an example of what we've seen as a small cell that's been done right and it's been very successful. But then what we've seen, we kind of coined the term, or some of our clients, called SMACRO, which is sort of the merging of a small cell and a macro, where you got a little bit of the flavor and a little bit of the advantages of small cell, but you still have some legacy requirements that are still there that are requiring, more equipment on the ground and, sub-metering for power and things of that nature. And what we see is that from a deployment standpoint, it's everyone's expectation that small cell is small cell is small cell. Let's get it done quickly. Let's get it done inexpensively. But the reality is as we tend to morph into this macro perspective, you add a sub-meter and you add more equipment on the ground, like Emil and Dennis said, you now have landlords that expect to be paid a full lease rate, or it takes you a lot longer to get the deployment done, or you're now subject to traditional leasing and zoning perspectives. So, I think the key is that when we've seen it done right, we've seen it done by doing things like keeping the equipment small so you can maybe keep it off the ground, working with utilities and right-of-ways and other master agreement holders, where you can knock out clusters of site instead of individual sites in one fell swoop. But at the end of the day, the key on the timing is still going back to the things we all have known for a long time, which is availability of power and availability of backhaul. And so, like both Dennis and Emil talked about, when you look at those things as available resources as part of your planning and part of your implementation, we find that our customers are more successful and we're able to meet those requirements. So it really comes down to, we're building a heterogeneous network. Let's have a process that's very holistic and heterogeneous, that sort of looks at all of these factors together and not doing things the way we may have done them historically over the last 20, 30 years with macros. Let's not have an RF engineer design the site, throw it over the wall to a site acquisition specialist, and they come back with 3 candidates. But instead, let's sit down together, maybe have a specialist that can do both RF and site AC and look at the overall network and have smart locations and flexibility in locations. And like Dennis talked about, understanding that, hey, some of these nodes may not be ideal in terms of the quality, but they're still going to have a very positive impact on the heterogeneous network. So that's kind of been our perspective, what we've seen so far, and we expect to see, as any deployments, new deployments and technologies, we expect to see it continue to be more towards the left side of the screen. So next slide. From a cost standpoint, these are not by any means proprietary to anybody, but they're just sort of ballparks of what we've seen on our end of successful small cells versus traditional macro cells on what the dollar impacts have been to deployments. Successful small cell projects over the last couple of years, we've seen come in at, the ballpark of tens of thousands of dollars, 20,000 on the CapEx side, and recurring OpEx, when you take into account all your OpEx hits, your lease, your power, your maintenance, hitting, 8,000 a year. Compare that to what we're all used to on the macro cell side, that's significantly better, and I think it will continue to be refined. And so we're seeing some success. We are seeing the macros where you kind of are getting, a traditional lease rate, even though you have the lower equipment cost, for example. So some meshing of those two ballparks of cost, but that kind of gives you a view of what we've seen on our end in terms of the impact to the cost structure with small cells. So that's it.
Okay, great. Thanks so much, Dan. Folks, we're going to start getting into your questions and a few others. I'm seeing quite a few questions about whether small cell backhaul is being done through fiber predominantly or microwave. I thought it was really interesting. I heard a variety of perspectives on that, but I know that, for instance, not to put not to put words in Dave's mouth or anything, but you know, during the last call, Verizon, the last quarterly call, we had Verizon executives talking about how fiber was basically all of their small cells, you know, as opposed to maybe, you know, 90+% of macro sites, you know, with some, you know, with some microwave. But it sounded like, you know, at least from Verizon's perspective, you know, predominantly fiber backhaul. You know, on the other hand, I did have some folks talk about the potential for Sprint, you know, the densification that they're looking to do, you know, potentially utilizing some of their spectrum holdings for wireless backhaul. I don't know if any of our participants have, you know, perspective on what they're seeing in terms of, you know, fiber versus microwave or other wireless backhaul.
Should we just jump in?
Yeah, sure.
Want to answer? Okay. So this is Dennis from Verizon. So, but that statement about being all fiber is accurate. But we also know that going back to our revenue and having to reduce cost, not only our CapEx, but operational expenses as well going forward. And it's a natural, this is a part of a natural evolution where we have to look at our reliability requirement, look at our battery backhaul requirement, and determine if that makes sense, because our customers want service at the end of the day. And if we say, well, you know, it's not going to be reliable and somebody else is going to provide adequate service, then our customers are going to go. And we can't let that happen. Mm-hmm. But we also need to do the best that we can, and we also have to reduce costs. So it's kind of a natural evolution to embrace different backhaul solutions, not just microwave, but the other, you know, point-to-point solutions that are available. And we're seeing being developed by not only our vendors, but also other folks that are out there. It takes time to develop them, but absolutely we're looking at that. And it's through these solutions that we're going to be able to provide the best service and most reliable service going forward.
Okay. Anybody else? Emil or Dan? Or?
I would just say, this is Emil here. I would just say that in all the carriers that we talk to, fiber is their first choice, lease line, microwave, and then in extreme cases, millimeter wave. But that, you know, it's almost fiber 100% of the time if they can get a fiber. And you know, Dan and others can talk to this. 2 or 3 years ago, it was hard to get a fiber locate on a utility pole. It's becoming much easier now. Now they know how to get street addresses. They know how to get fiber or cable access there. So that issue that you saw maybe 3 or 4 years ago is becoming less of an issue now. It's still there, but definitely the first choice by all the carriers we talk to is fiber.
Okay. Dan, any thoughts?
Yeah, definitely. This is Dan. I agree. You know, we're seeing predominantly all fiber deployment so far. And I think part of that is that's kind of the low-hanging fruit as well. You know, on the deployments, you know, when you look at where there's available resources and focus there first. So I think as we mature in the deployment, we're going to start seeing the need for other backhaul solutions. And you know, I was reminded by one of my engineers the other day that we still have some elements in the 3GPP 4G standard that enable things like in-band backhaul within the LTE channel that haven't really been developed or leveraged yet. So, you know, we're going to continue to see some things that maybe we don't even realize that are going to help, you know, enable that backhaul. Obviously, that taps into your capacity when you do that, but could very well help you with a quick deployment. So. I agree. We haven't seen hardly any microwave at all yet within true small cell deployments.
Okay. We had another.
And Kelly, just one clarification. We're talking about enterprise small cells, not the small home office ones that enterprise knows. Those are cable modems and, you know, DSL type connection, broadband connections, wired connections. This is enterprise. just
Yeah.
to differentiate that.
Yeah, absolutely, absolutely. Enterprise or carrier, I think is primarily what we're focusing on. So we did have a question about something that Dennis mentioned, the need for better SINAR, and the question was addressing the need for better SINAR and CQI to get higher data rates. Dennis, since you touched on that, can you talk a little bit about that? Because
Sure.
I heard from a number of people in the small cell space, talking about how, when you get these things in, that they are really seeing quite good capacity gains. And you touched on that in terms of, getting these things close to customers and how that changes the sort of the RF game.
Okay. So when we think about SINAR, it's going to be signal to noise ratio plus interference. And when we want to push more data, we're going to go with higher modulation code schemes that have less and less room for error in that transmission. So we have a list of modulation code schemes that we can use, but we can't use, but we're dependent on SINARs to pick the right one, to have the right amount of blur so that we don't have to constantly send retransmissions and achieve not as much as we want. But there's two components. There's thermal noise, but also and propagation also comes into it, but really cell to cell or intercell interference is going to drive our SINAR numbers. Because if you put two cells right next to each other on the same channel, then right in the middle of them, you're going to have a 0 dB of SINARs, and it's just not going to be good. You really need much better SINAR. So if you can isolate your cells, either through down tilt or proper placement, then you can achieve higher SINAR, which means you can deliver more data. And if you're delivering more data or faster data, then the number of people you can service is going to grow. But as soon as you reach the point where let's say if you're providing a certain number of people data, if you add another person and that amount of data that you're able to supply goes down because you don't have the gross throughput, then everybody starts queuing up at that point. And as they start queuing up, the throughput goes down further. And so if you hit your capacity limit, you're just done. You absolutely have to maintain the largest pipe that you can get, and it's going to happen by getting the best SINAR you can get.
Okay. Dan, any thoughts on that?
Yeah, I think the other thing, and actually Dennis pointed it out earlier in his presentation, is proximity between the subscriber device and the cell itself have huge impacts on that SINAR. It keeps everybody at lower power because they're not having to transmit through as much distance and or clutter in the environment. And so inherently with small cell deployments, you're going to get the overall system-wide SINAR and noise floor to be more in line. But that's only if you do it well in a way that is coordinated with your macro network, and you don't ignore your macro network. You have to constantly make sure that you're optimizing the macro network to take advantage of that densification, so that you don't have an overlay-underlay scenario where you're not improving that SINAR situation.
Okay. Great. We had another question. Are the major operators monitoring and maintaining small cell sites in-house or outsourcing to third parties to save OpEx costs? I can speak to that to some extent, just in terms of what I heard from folks across that I was talking to in the course of reporting here. We had folks like PCTEL, on their last quarterly call, talking about how they generally expect sort of neutral host model, much like DAS has been in the past. Even if each individual site might not be neutral host yet, although that is a goal of the small cell forum to work toward, that we are going to see the Extonets of the world, the Crown Castles of the world, putting more and more energy into, putting those sites up. And in fact, I think Crown Castle, in its most recent quarter, said that they had spent more money putting in small cells than they did on macro sites. Emil, is that, do any of our participants want to speak to that in-house versus outsourcing? I know that in the case in San Francisco, some of those, were Verizon Wireless owned and operated, and, it was a split, and some of them were Extonet. So, I think we're seeing, that carriers are not necessarily looking to to re-own a whole lot of towers now that they've mostly jettisoned tower assets. It seems like, from what I'm hearing, that we're going to see a mix of some in-house and some outsourcing as far as small cells go. But participants, any thoughts on that?
So when it comes to the signal source, or your eNode Bs are going to be the signal source, and whether you're providing the small cell footprint or antenna system, or you're relying on your crown castles or your extenet, they're going to provide the conduit through which we're going to deliver signal. But after that signal reaches the customer and the customer starts processing that call or connection, those metrics are being kept track of at the eNode B. So we're getting receive levels, we're getting return loss information, which isn't always useful. We're getting noise information about the ambient noise that's present, and we're monitoring that. I mean, that's part of our operations and maintenance platforms that we hold so dearly. And in all cases, your crowns and extenets are going to want to see that information, because they're going to control the gain levels, and path balance issues associated with those systems are going to be reported by the eNode B, and they often want to know what the eNode B is seeing. But when it comes to the traffic that's going through it, they don't have any visibility to that. But it's often good to partner with them so that they understand what's going on and where they can engage to improve overall performance.
Okay, great. Another question for you folks. I'm wondering if we can talk about real-world deployments. I know we have some folks on here who have seen these things in the real world. Obviously, Dennis, Dan. Can either one of you, talk about real-world small cell deployments? What the deployment goal was in terms of coverage or capacity, and sort of sketch it out for us how how those things have played out. Dan, maybe we can start with you.
Sure, you bet. So we've seen the bulk of the outdoor small cell deployments have been in tier 1 markets like Chicago. We're seeing them start hitting some of the tier 2 markets like Seattle and Denver. And what we're seeing is definitely the customer looking for densification, and so there'll be a set of candidate hotspots that need to be addressed, but we're not necessarily being asked to address each and every one of those hotspots, but instead to go through a process to sort of optimize the deployment process to say, okay, which hotspots can we address and which ones can we address on our time and budget constraints so that we can get it done within this project schedule. And so at this stage right now, it's been more of a like I said, a low-hanging fruit. There's a lot of opportunities for improvement, so let's focus on the ones we can get done quickly and within our budget, and make sure that they're within those hotspots. And then we're cross-referencing those hotspots where our clients have master use agreements, where they have right-of-way or utility agreements in place. And so that's really been the focus. And then, of course, where they've also got access to fiber assets through their backhaul partners. So really that's the focus, is where are the assets, where is the backhaul, where's the need, and look for the convergence of all of those things in a way that can be done on time and on budget. So I don't know if that answers the question, but that's really been the crux of all the deployments so far.
Yeah, Dan, that characterized that very well. And when it comes to the need, there's 3 elements that we look to determine how valuable an asset is going to be, or how valuable a cell site is going to be. And it's going to depend on the signal conditions that are there, because if there's a lot of macro cell there that is going to interfere and reduce your SINAR, then there's the capacity element is going to be challenged. We also need backhaul, and we also need people. So if we have a backhaul in a particular location, we need to keep that in mind, but we also need to make sure that we're looking for the number of people that are present and the SINAR conditions that we can create. And basically that'll tell us how much time that we're going to capture with that cell site, or how much capacity. But then everything that Dan said is right on the money.
Okay. And I'll actually add to that real quick that where we're seeing less than ideal success is due to a few things. One being, we may have hundreds and hundreds of applications going into a utility that has an approval process, or even a jurisdiction where, a jurisdiction has built a process to handle, tens of applications a month of macro sites, and now they're getting hundreds, if not thousands, of applications in that same time period. And it's a first in, first out kind of process still. And so what we're starting to see is utilities, we're starting to see jurisdictions almost go back to some of the same things that we saw in the mid-90s with the large PCS build-outs, which was jurisdictions and utilities starting to come back and say, hold on a second, guys, we may need to put a moratorium here until we figure out how to process all of this. We're being overwhelmed. And so there's some risks right now in terms of the aggressiveness by which deployments are trying to be pushed out, where it's going to take some tapping into our experiences of this happening in the past to really do a good job of not letting it get into a moratorium situation.
Okay. We've had a couple of questions in terms of power and small cells. As sort of the vision for these things has been, mounted on a light pole, as we saw in some of the pictures here, mounted, maybe on the side of a building. One of the things that I commonly heard was, was master use agreements, with municipalities, with utilities, kind of helping out with scalability in terms of, having access to power and a whole lot of sites. So the question that we had from our audience was how much runtime was required for small cell backup power. Dan, I don't know if you or Dennis can speak to that in terms of, helping folks understand, how that compares to maybe a traditional macro site, and what folks are looking for there when it comes to power requirements.
Right, and that has been a large question, and in many cases, if we go in trying to expect we're going to get macro cell backup power on the order of 8 hours, we're going to shoot ourselves in the foot. Mm-hmm. But so each region, each location around the country is going to have to look at the problem they're trying to solve and what realistically they should be deploying. In some cases, we're going to deploy without backup power because we're limited on space. And if we just want that perfect location, and then we're going to have to make some sacrifices. Now, we always have our macro system behind us that's extremely reliable, and we don't have to give that up. So even in the worst case scenario, we're going to have service and we're going to work through it. And having that gives us the ability to make the judgment call in the cases where we have to give up backup power. I think, and it depends on where you are. If you're in Southern California, the odds of you seeing an extended outage are low. But if you're where weather happens, then you can see extended issues. But we're always going to try and provide the most reliable service. But going forward, we have to embrace the situations where backup power is a challenge, or it's going to limit us. So like we talk about 8 hours for macro, or 4 hours or less for small cells, and it's something that the individual designer and region have to decide for themselves.
Okay.
Yeah, and I would add that a typical like strand-mounted small cell, it's drawing on the order of 2 watts of power, maybe a pole-mounted small cell 5 watts versus 30 or 40 watts of power for a macro cell remote radio head. So, if we avoid the tendency for smacros again and really truly do a small cell, now the same amount of backup power you have available, whether that's a battery or whatever it is, can now last a lot longer. It's pretty straightforward. And I think the other thing that we found with building implementations is when we can tie into the building power versus having to bring in a new power with a new meter, oftentimes we're able to convince the landlord to let us tap into their life safety systems in that building, which then provide additional backup power, whether that be a generator or whatever they have.
Okay. Emil, I wanted to come back to you. One of the points that you made was really talking about how the use of unlicensed spectrum, could really mean jump-starting for small cells as we know them. Can you talk a little bit more about, how you expect to see that sort of licensed spectrum, unlicensed spectrum coexistence, and and what that's going to mean for network architectures?
Sure. So if you look at what the LTE Forum and LAA, the 3GPP version of that, they're utilizing LTE in the ISM bands and in the 5 gigahertz bands that Wi-Fi occupies. It's unlicensed spectrum, so they're free to use it. And so carriers are looking for a way, and I think Dennis may have talked to this, to keep their customers, reduce churn, and increase revenue, and really give the end user the best experience. So utilizing that, you're able to get fantastic download speeds because you have this a large 20 megahertz carrier that you can utilize. But that's downlink only. It has to be tied to that LTE-U small cell, and it is a small cell. It's operating at 5 gigahertz, so it's limited to the power spectral density of essentially a cell phone. So it can only go so far with regards to the power it has, but that has to be matched up to a carrier-grade small cell, and that carrier-grade small cell provides the uplink, and they're coordinated and tied together. There is an interface between that LTE base station and the small cell. So that coordination between a 5 gigahertz band small cell and a licensed band. So, and that could be any of them. It could be in the AWS band, 700 megahertz, 850, PCS. All of those have to be coordinated. So there's a huge amount of work that will come with regards to optimizing these systems, especially, particularly for outdoor situations where it really becomes prevalent. You'll see a lot more optimization work need to be done and coordination with regards to that. But this unlicensed frequency, Wi-Fi is by far the most prevalent use globally. And so this is just another way to utilize that spectrum for carriers to take advantage of that going forward. So there's a big advantage. And then you have this multi-fire alliance, which is like LTE unlicensed. It operates in the same band, but it does uplink and downlink. But you don't need an anchor base station or an anchor base station. It is a standalone LTE base station. You don't need a carrier to operate that. So you may see new entrants come in, enterprise owners, building owners, deploy their own LTE base stations to provide service. I think that's the goal of that. That's probably a little ways off. And obviously the device ecosystem has to get out there. But you're already seeing trials being put forth by Verizon and AT&T wanting to do this, and then looking at how to utilize the spectrum to the best of their ability. And I think that just leads into 5G deployments as we get a better understanding of how things work at 5 gigahertz and at 60 gigahertz. That understanding of how to deploy in those bands on a large scale will feed into the 5G conversations that are just around the corner.
Okay, great. Well, I'm going to take this opportunity to thank our panelists. We're going to have one last question. I'd like each of you to walk us through quickly what trends do you think we'll see in small cells this coming year and going forward. Emil, since you sort of started down that path, I'm going to start with you and tell us what you expect.
I expect to see the deployment of small cells in the unlicensed band proliferate throughout the U.S. and a lot more carriers start to embrace it and utilize both 5 and 60 gigahertz bands with licensed bands. Okay.
Dennis?
Like with regard to small cells, we're certainly going to see the number of small cells being deployed increase, and it's going to continue to increase as we go forward for the visible future. But we're going to have to deploy where it's smart and embrace new technologies for backhaul. And master agreements are going to be critical to that effort. Wherever we can form an agreement with somebody that has a location or backhaul, then that's what we have to do. And that's what we will do. And making it easier for folks to do that and develop those agreements will be critical.
Okay. And Dan, your thoughts on small cells moving forward?
Yeah, I think in the near term, I think the trend that we're already starting to see is two things. The first being that the convergence of the enterprise and the mobile network operator, we're getting more requests from enterprise to say, hey, we want to take control of our need for wireless data and accessibility. And so I think you're starting to see, the network operators in the enterprise space kind of work together more where the enterprise can drive some of the capital spend, so, like Emil talked about. And I think secondly, the skill set of those that can deploy these networks, I think you're going to see that skill set be demand to be more technical in nature. So take our construction teams, for example, our successful construction team members that are deploying small cell are more technical in nature and less, shovel operators in nature. And so I think you're going to see that trend for across the board for the staff that are performing the work to be a little more adaptable and a little more technology focused.
Okay, great. Well, thanks all of you for joining us today. I'd like to thank all of our panelists and all of our audience members. The slide deck for this presentation will be available after the webinar, and the webinar itself will be archived on rcrwireless.com. Don't forget to download that special report, which is available for free. Thanks again for joining us here at RCR Wireless News.